Hello, and thank you for stopping by. Thank you to Saul and George for putting this together and for inviting me to speak. The views I'm going to present here are my own that I've gathered over the last couple of years I've worked with the cannabis products. There is a new medical revolution threatening the fabric of healthcare as we know it. The revolution is based on the little understood endocannabinoid system. The ACS was only identified in the 1990s and continues to face a lot of scrutiny. The quest for this knowledge is rooted in the enigma known as cannabis. Cannabis is a plant that evokes very mixed feelings from people of all walks of life. Many consider it a gateway drug, while others believe in its healing properties. So in the next couple of slides, I'm going to explore why cannabis is and continues to be such a conundrum. So this discussion is divided into four. There's a little bit of introduction where we just detail, I'm going to provide details of cannabis. Then I'm going to give you a few slides with the endocannabinoid system, then discuss cannabidiol pharmacology, and end up with the opportunities I think that exists for us in the Society of Toxicology. So I wanted to highlight the dollar numbers associated with the cannabis market. The worldwide continued compound annual growth rate is expected to grow by 32%. In 2019, it was estimated at 300 million, and in 2024, it will reach $1 billion US. The highest producers are both legal and illegal. Legal include Europe and North America, while the highest illegal producers are Africa and South America, which account for almost 50% of all production. The highest global cannabis consumers are Africans again, and these are illegal consumers. Israel has led the way, is a trailblazer in terms of growth and development of cannabis products. Iceland at 18%, and US at 16%. So, cannabidiol. It is one of 142 cannabinoids found in the cannabis plant. It was first isolated from the American hemp and psychotropic Egyptian hashish in the 1940s. The final structure would not be elucidated until 20 years later. The non-psychoactive CBD. Non-psychoactive because it has no CNS effects. It does not cause any kind of addictive or hallucinatory effects. Is a Schedule 1 drug, but it is sold worldwide. Schedule 1 drug simply means that it has no medical benefit for human beings. It has no medical benefit or value for human beings. However, CBD continues to be sold worldwide. Currently, 14% of Americans are using CBD. They're using it for pain, anxiety, insomnia, arthritis, and majority of those that take it actually take it for pain, followed by anxiety. Insomnia comes in third, and arthritis comes in last. And these are just a subset of the reasons why people are taking CBD. Majority of the users, 20%, are aged between 18 and 29 years old, while 16% are aged between 30 and 49 years old. Women take it for different reasons from men. Women take it for anxiety, men take it for sleep. To date, there are 2,850 publications and 154 clinical trials. 42 of these are not yet recruiting, and 28 have withdrawn their clinical protocols. So cannabidiol has been a major part of drug conversation for the last couple of years, at least since the year 2000. Cannabis was one of the first plants to be used by man for food, medicine, and religious rituals, as well as social recreational purposes. Medicinal uses were documented by the Persians, the Iranians, the Indians for over 1,000, for maybe 3,000 years. Assyrians in South Iraq also document use, and a prominent Chamberlain of the Caliphate Council in Baghdad recorded the use of cannabis in treating his son's epileptic condition. Ancient Egypt, Greek and Romans, as well as Europeans also document the favorable uses of cannabis up to the late 1800s. Recreationally, Russians, Arabs, and Africans record extensive use of cannabis for recreational purposes. Other than that, cannabis plants exhibit wide variations in the quantity and types of cannabinoids they produce. So why all the conundrum with cannabis? There are 3 recognized plant families in this species. In this species, Cannabis sativa, Cannabis indica, and Cannabis ruderalis. Literature suggests that Cannabis ruderalis is the putative ancestor of the sativa and the indica species. Approximately 18,000 years ago, the ruderalis grew wild in Central Asia, in the south part of Russia. The species then migrated northwards to Russia, Europe 15,000 years ago, and due to the cold northern climates, Cannabis ruderalis evolved into a tall Cannabis sativa species that we know today. At this time, Cannabis sativa was a hemp-producing plant used for production of fiber, cloth, and food. Cannabis sativa is a dominant strain that migrated to South and subsequently North America with the Spanish invasion. Approximately 5,000 years ago, Cannabis ruderalis apparently migrated southwards and encountered warm climates in China and India that gave rise to the Cannabis indica species, known for its medicinal properties, widely reported in ancient Chinese and Indian literature. The Cannabis indica migrated west via trade routes to the Mediterranean regions, arriving in Africa approximately 3,000 years ago. In the last 50 years, a lot of hybrid strains have been developed from Western cannabis and the Eastern cannabis species. That's your sativa and your indica. And they have created thousands of hybrid strains with qualities representing the parent land races or the original strains that grew in their home environments. They have different cannabinoid profiles and allow users to select their preferred cannabis properties. By 2014 in the US, there were 779 marijuana strains and 400 hemp strains. This information then begs for the question, what is the difference between hemp and marijuana? In today's terms, the simple answer is THC content. Levels in hemp cannot exceed 0.3%, while marijuana can have levels ranging from 1 to 30%. Therefore, in today's terms, hemp is used for making fiber or hemp fiber. It can be used to produce oil. It can also be used to produce human food as well as animal food. The hemp also has CBD, a cannabinoid profile that includes CBD and 0.3% THC. On the other hand, marijuana is used for pharmaceutics as medical marijuana or for recreation as THC. CBD, it contains the pharmaceutics variety contains CBD and THC content of that ranges between 0 and 30%, as well as other cannabinoids. Recreational marijuana contains a high percent of THC, and all of these products exist in the marketplace today. And for individual consumers, they have to go out there and figure out what it is they are looking for. The mixture of cannabinoids in the plant is referred to as a phytocannabinoid, and it represents the plant's total cannabinoid profile. Phytocannabinoids are synthesized and stored in the trichomes of the flower. Briefly, cannabinoids are derived from olivetolic and divarinic acids, which are activated fatty acids, which form the precursors cannabigerol and cannabigerovarin. These are the precursors of tetrahydrocannabinol, cannabidiol, cannabichromine, among others, and also are the precursors of tetrahydrocannabivarin, cannabidiolvarin, and cannabichromvarin, among others respectively. When ingested, these phytocannabinoids interact with the ECB or the endocannabinoid system, The flower products account for 90% of this plant's revenue. The cannabis plant, however, has other uses that include food. Omega-3 rich oil and seeds are used in developing food products. The straw, or the middle stem, that gives rise to paper, rope, and cloth, etc. The plant is also eco-friendly and is used as a key player in bioremediation activities because of its ability to recycle carbon. It has been used in the cleanup of the Chernobyl nuclear disaster site. At the moment, all other uses of the cannabis plant account for only 10% of the revenue. However, there's a potential for growth there. The endocannabinoid system is made up of 4 major components: the ligands, the receptors, the synthesizing enzymes, and the degradative enzymes. The ligands include anandamide and 2-arachidonyl glycerol. These are the 2 major and the most studied endocannabinoids. Saying that they are major doesn't mean that there aren't others that are known. There are others that are known, but we don't know the extent to which they influence our body systems. Some of these include palmitoyl ethanolamine, or PEA, oleoyl ethanolamine, OEA, steatoyl ethanolamine, SEA, NADA, DHEA, arachidonic acid, vanilloid, EPEA, 2-AGE, and 1-AG. And all these ligands exist in our bodies. They are continuously active. They are continuously produced when the synthesizing enzymes are active. The receptors include cannabinoid receptor 1 and cannabinoid receptor 2. These are the 2 major and most studied receptors. However, there are a myriad of other receptors. Some still remain unknown. GPR19, PPAR-Gamma, GPR55, TRPV1, FLAT, GPR119, and PPAR-alpha are just some of the significant receptors that engage with the endocannabinoid system. The synthesizing enzymes include diacylglycerol lipase, which is the enzyme responsible for synthesizing 2-arachidonyl glycerol. The NAP, PLD, and the N-acetyltransferase are responsible for synthesizing anandamide. There are other enzymes involved in parallel pathways that produce both anandamide and 2-arachidonyl glycerol, and they are specially represented in our body. So they don't exist in all compartments, and when they do, they are not active constitutively. So they are sometimes called upon to act when the other synthesis enzymes are not working. However, we know that they are present and they can be activated. Degradative enzymes, we have 2 major ones: FAAH, of fatty acid amide hydrolase, as well as MAGL, or monoacylglycerol lipase. And these 2 are the major enzymes involved in the degradation of 2-arachidonyl glycerol and anandamide. There are other degradative enzymes. Little is known about them. These include the cytochrome P450 system. 2D6 has been implicated in some of the areas of metabolism. COX-2 and LOX-2 are also involved. Fatty acid binding protein is involved in transport of anandamide and has actually been implicated in elevated levels of anandamide and disease. FAAH2 is a splice variant of FAAH1 and is known to be active in some sectors, but not much is known about it at this moment. So as you can see, the system is very complex, and the inner circle represents the only space where we are actively studying. The outer circle represents all the other possibilities that exist with this system. So when endocannabinoid signaling goes wrong, many diseases may result. On this slide, we are showing all the possible diseases that have been associated with deregulated endocannabinoid activity. On the right, in red, shows what happens when overactivation of cannabinoid receptors occurs: liver injury, obesity, metabolic disorder, diabetes, appetite, nausea and vomiting, endometriosis, and so on. When endocannabinoid activity is insufficient, then we have another list of diseases that can occur from the same system: osteoporosis, arthritis, rheumatoid arthritis, addiction, anorexia, chronic and neuropathic pain, neurodegeneration, multiple sclerosis, spasms, Parkinson's, shock and hypotension. And this just presents a laundry list of diseases that can occur when there is no balance in the endocannabinoid system. Endocannabinoid imbalance will normally result from, in the case of excess activation, we have a decreased amount of FAAH and MAGL, which are the two enzymes that degrade anandamide and 2-arachidonyl On the other hand, insufficient endocannabinoid activation will result from excessive overactivation of the same enzymes. If we find a way of balancing or complementing the endocannabinoid system, we can probably find a way of mitigating a lot of these diseases. And in the literature today, there are 2,800 assertions that have one disease or another that is listed on these things. These diseases are in the top 10 diseases that associated with morbidity and mortality globally. And it doesn't matter which country you look at. The diseases shown in bold are major diseases that afflict individuals in all of those countries. So it is of global concern and needs to be addressed if we are going to improve the health of our people. So here is a laundry list of cannabidiol's direct actions at various receptors. Cannabidiol is known to inhibit the activation of fatty acid amide hydrolase, the enzyme that is responsible for metabolism of anandamide. Diminishing the activity of that enzyme means that you will increase the activation of the synthesis, or rather you'll increase the levels of anandamide at the synapse. Increased anandamide will activate CB1, CB2, and TRPV1 receptor. Now, CBD has no direct effect on CB1 or CB2, but rather it relies on the increase in anandamide to activate these receptors. CBD, however, does directly activate TRPV1 receptors, which are responsible for diminishing ROS in the cells. CBD also has an indirect influence on mitochondria, the mechanism through which there is very little understanding, and also directly activates PPAR-Gamma, inhibits GPR55, and has some activity at GPR3, GPR6, and 12 that is completely unknown, but has direct agonism at the 5-HT1A receptors. So this is a laundry list of neurotransmitter systems that are impacted directly by CBD's activities in the cells. There are some people who have suggested there may be as much as 65 targets, but that science has not been completed. On this slide, I wanted to show how CBD interacts with all the other ethanolamides that are created together with anandamide. CBD will inhibit FAAH, the enzyme responsible for its metabolism. That means that when you've inhibited FAAH, levels of anandamide, AEA, and OEA and PEA, the other ethanolamines that are present, will go up because they are not being metabolized. Increase in anandamide means that there is more anandamide hanging around, and also more anandamide going through the COX-2 LOX cytochrome P450 metabolism pathways that will increase anandamide metabolites through the COX-LOX pathway. It will also increase anandamide, OEA, and PEA, and their ability to activate PPAR-alpha in the nucleus. These metabolites that are created from the COX-2-LOX CYP450 pathway, along with AEA and OEA and PEA, will also activate the TRPV receptor, which is present on the which is an ion channel present on the membrane. They will activate the CB1 receptor and the CB2 receptor, also present on the membranes. These three work in synergy. One activation of one can lead to the activation of another, or activation of one can enhance the activation of another. At the same time, the metabolites will also activate COX-2, PPAR-alpha, and CB2 receptors on immune cells. And the mechanisms behind the activation of immune cells are really, in a nutshell, just to decrease inflammatory pathways. And that's a whole science by itself. That's another 30-minute talk, and we wouldn't even cover half of it. And they will activate those pathways. They are responsible for decreasing inflammation through that pathway. So CBD serves to activate cells, normal body cells, as well as immune cells, and so attacks multiple pathways and receptor families in order to decrease the effects of inflammation in the body. The presence of pathogens or damage activates the immune system and increases pro-inflammatory cytokines spewed out by the microglia in the brain and macrophages in the body. On this slide, I want to show that cytokines serve as a link between arthritis and mood disorders and activate three significant pathways simultaneously, all of which can be impacted by CBD. A kynurenine pathway plays a significant role in generating cellular energy metabolites such as NAD+. Kynurenine is derived from tryptophan by the action of indoleamine oxygenase in immune cells and tryptophan deoxygenase in the liver. During normal brain activity, the kynurenic acid pathway in astrocytes dominates activities. Kynurenic acid is a neuroprotective agent that directly inhibits NMDA activity and indirectly modulates NMDA receptors via negative allosteric modulation of alpha-7 nicotinic receptor. Now, glutamate is a neurotoxicant. Kynurenic acid also activates GPR35 and AHR receptor, decreasing cyclic AMP-induced calcium channel activation and cytokine release by macrophages, respectively. An increase in cytokines activates the kynurenine pathway, which is upregulated to generate adequate levels of NAD+. And as a result, quinolinic acid, the precursor to NAD+, is in excess and is known to induce neurotoxicity by activating NMDA receptors directly, inhibiting glutamate reuptake by astrocytes, thus increasing the amount of glutamate at the synapse and inducing neurotoxicity, which destroys astrocytes and glia as well, increasing reactive oxygen species, disrupting the blood-brain barrier, and diminishing the levels of protective kynurenic acid. In parallel, cytokines increase the levels of neopterin due to activation of guanosine triphosphate cyclohydrolase or GTC1 enzyme that converts GTP or guanine triphosphate to neopterin. Neopterin is a precursor molecule to tetrahydrobiopterin. Now, tetrahydrobiopterin is important because it is a cofactor that enables the activation of that enables the functioning of monoamine pathway enzymes that enable the the synthesis of norepinephrine and dopamine. And once tetrahydrobiopterin is diminished, there is diminished levels of norepinephrine and dopamine, which have got their own significant consequences I will describe shortly. Cytokines also increase mitogen activated phosphate kinase that upregulates serotonin, norepinephrine, and dopamine transporters due to the decrease in norepinephrine, dopamine, and serotonin at the synapse due to cytokine activation. So how does CBD help? CBD does three things. One, it decreases inflammation mediated activation of microglia. So microglia are induced into an activated phenotype when there is damage or there are pathogens present. These activated macrophages are responsible for releasing pro-inflammatory cytokines. So CBD can shut down the activation of that enzyme by inhibiting the release of cytokines. CBD can directly inhibit activation of IDO or indoleamine oxygenase. It inhibits the activity of the enzyme and therefore can decrease the activation of the kynurenine pathway. Last but not least, CBD will inhibit alpha-7 receptor activation directly, thus decreasing glutamate release from astrocytes and microglia directly. So a deactivation or a diminished neurotransmitter system has detrimental effects of its own. In the VTA, diminished dopamine leads to anhedonia and mood disorders. In the locus coeruleus, norepinephrine leads to cognitive impairment and also depression. Raphe nucleus, diminished serotonin leads to anxiety and depression, while pineal gland leads to disrupted sleep patterns. And therefore, if you diminish glutamatergic activation and reduce the kynurenine activation, pathway activation, which will subsequently lead to a decrease in neopterin because the pro-inflammatory cytokines are no longer available to diminish or to activate GTP-CHA, then you can improve the quality of life in these patients. Most of our patients are taking cannabidiol, and if cannabidiol is activating these multiple pathways at the same time, it is now possible to see why there is such demand for it. As we come to the end of this talk, I wanted to end this conversation with this slide because I believe it represents a lot more that we need to actually have a conversation about. So when we ingest food, we all know that there is a recommendation to ingest more of omega-3 and not too much of omega-6. And why is this? Let's see if this picture on the left can shed a little bit more light. So when we ingest omega-3s and omega-6 fats, they are incorporated into cell membranes. Omega-3 shown in green and omega-6 shown in purple. And as you can see on the cell membrane, both are incorporated equally. When required, they are released from the membrane and they are used to synthesize different molecules. On the left, we have arachidonic acid, which is used to synthesize anandamide and 2-arachidonyl glycerol or 2-AG. And these molecules are our endocannabinoids that are derived from omega-6s. At the same time, arachidonic acid can be metabolized through COX, LOX, and cytochrome P450 to create a whole slew of eicosanoids that are involved in signaling pathways that relate to inflammation. On the other hand, omega-3s can also be synthesized in the body into DHA or doxohexanoic acid, and they are synthesized into dihydroepiandrosterone and deoxyhexanoic glycerol, which are also endocannabinoids that are involved in signaling, and we will see how all of these interact. And they can also be metabolized used by the LOX system or lipoxygenase system into eicosanoids that also are involved in signaling pathways related to inflammation. The inflammatory the eicosanoids that are derived from DHA are normally anti-inflammatory, while those that are derived from arachidonic acid are pro-inflammation. Now, when you do not have omega-3 in your diet, you do not have anti-inflammatory signaling eicosanoids, you only have the pro-inflammatory ones. But how do all these play out together? On the right, we have a simple schematic showing how omega-6 diets will decrease dihydroepiandrosterone, EPEA to DHG, and if you eat too much in omega-6, you will decrease that group of endocannabinoids that are present, that are required and are pro-inflammatory and are anti-inflammatory in nature. If you eat too much in omega-3 diets, you also shut down arachidonic acid. You shut down anandamide and 2-AG. At the same time, omega-3 diets will also increase the signaling pathways associated with DHEA and EPEA, while those ones of omega-6 will be pro-inflammatory and will increase the 2-AG and anandamide. But at the same time, they are also shutting down CB1R receptor and TRPV1 receptor signaling and inhibiting endocannabinoid plasticity, while omega-3 is pro-endocannabinoid plasticity and CB1R receptor signaling. So this begs the question, our diets are more omega-6 containing than omega-3 containing. Could that be contributing to the imbalance of the endocannabinoid system? Again, I couldn't help but end this talk on that note, and I hope that all of you will go back and view endocannabinoid science with a new lens that can help support and increase our knowledge on this system. Thank you. Thank you very much for your attention. Please do not hesitate to send me any questions you may have. My name is Harriet Kamendi and my email will be hkamendi@gmail.com. Thank you for your attention.